Alright folks, so what I'm going to do in this video is I'm going to give you a crash course understanding of, in this case, UE. UE is universal elimination. More or less what you'll be given in your proofs is you'll be given a statement that looks like this. For all of x, if x is a d, then x is a b. Now let's go ahead and understand that we're talking about ducks and birds just for the sake of argument. What UE allows us to do, UE allows us to move from a universal claim, which you should note has a placeholder x. It has a placeholder x, and the x binds over this entire statement. One of the things that I've been noticing in homeworks is folks are forgetting to put their parentheses in the proper location. If you were to write this type of statement in this way, well, that's wrong. The x here is limited to dx, and bx is an unbound variable. So remember, when you write down translations, or even when you're writing down these sentences, we need to be mindful of the parentheses. Namely, they go here. But back on topic. Universal elimination allows us to move from a universal claim to a claim about some particular thing. So let's draw our universe here. So let's say we have a universe. Let's make our universe blue. In our universe, we have a box. Let's call this the bird box. And within that bird box, we have a smaller box. Let's call this the duck box. What our universal claim in 1 says, our assumption in 1, is that for everything in the universe, if it is a duck, then it would be a bird. What universals allow us to do is universals allow us to move from a generalization, an x, a y, or a z, to some particular thing. So we can move from, for all of x, if dx then bx, to something that looks like this. dA, 1 UE. Oh, actually, it would be dA arrow BA, 1 UE. Could also move to dB arrow BB, also 1 UE. We could also go to dB arrow, actually let's make that a C, DC arrow BC, also 1 UE. What we can't do, however, we can't do this. We can't do this because notice that we've changed the letter from x to something different. When we replace the x for UE, we have to replace it with the exact same letter. We can't just replace it with any old letter that doesn't match the other one. So let's say that we had something that was a relational, and I'm going to make it a complex relational. So let's say we had for all of x and all of y, LXY. X loves y. When we do this one, the thing to note is for UE, we're allowed to use UE on this one. However, we have to do it piece at a time. We have to do the first outside x first, then we get to do the y. So our first move would be L, A, Y, and the y stays there. 1 UE. We could also have done it this way. LBY from 1 UE. Then, if we want to get rid of this universal, then we're allowed to replace it with whatever letter we want. We could replace it with a C, a D, or even another B. We're allowed to replace it with any letter, including any letter that's already been introduced into our proof. In this case, we would cite, let's cite 3, UE. While there are restrictions on UI, that's not an I, UI, and on EE, there aren't any restrictions on universal elimination. And by restrictions, I mean the little letters right here. With universal elimination, you're allowed to introduce from a universal any little letters that you want, so long as those letters are between A and W in our alphabet. Remember, X, Y, and Z, those are placeholders. And in being placeholder letters, they're going to be things that don't stand for any individual items. They stand for a placeholder, for things that could be the case, but we don't necessarily are. In contrast, A through W is a stand-in for particular items, particular people, particular animals, or particular things. In the next video, I'm going to go through UI and also show you how it is limited, but also the certain circumstances in which we can and can't use it.